Han's out today, so I'll make sure you get this recorded. So we kind of talked about unit tests and how we're going to approach that this morning. And then for big O notation, we'll do that in the afternoon. And it's basically big O notation is a way of if you've ever thought about it when you're writing your code, you've probably seen like, oh, I wrote this solution this way, someone else wrote it that way, or maybe you thought like I can write it this, take this approach, or I can take this other approach. How do I know what is the best way? It is all that all that matters that your code works in the end. Oftentimes, yeah, that's the first place we want to get to, but some solutions are more efficient in what they take to accomplish. So I will say, like on in your front end projects and even your full stack projects, you could write very inefficient algorithms, and the data sets you all are going to be using, it won't be noticeable. But if you are in an interview and someone says, "Hey, I want you to look at these two functions that are solving the same problem," which one is more efficient? You should be able to look at those two functions and give an answer to that question. And that's what big O notation will allow us to do. It allows us to look at the general trend of a function and its worst case scenario, so you can determine which function is going to be more efficient at a high level. That's what we'll be doing there. So this morning, unit tests, functions, afternoon, big O notation. And then what I do after that is there's data structures for list, binary search trees, and hash tables, which are generally just objects. And those exercises are about writing those data structures from scratch. However, in JavaScript, we have an array. Probably won't find yourself in a situation needing to use a binary search tree in JavaScript, so we don't necessarily have a method for that or an object for that. And hash table is just an object. We already have JavaScript objects. So these will be released as like kind of like optional exercises as you want to like dive in deeper into like data structures and whatnot. So I found that by making those kind of like optional, it gives us a lot more breathing room in this week to even knock some content out from week 11, because week 11 tends to be actually a bit more complex because React comes into the picture. So yeah, with that said, any quick thoughts or questions before I introduce the unit test Jest exercise? Yeah, Ahmed.
I was just curious, for the unit test exercise, like, are we basically going to be writing those files that used to be provided to us in those exercises, like the ones where you write the functions and then like if the function is correct, the test will pass.
Yes, exactly. Yep.
So we're basically writing those files.
Yeah. Yeah, you're gonna learn how to write that. Yeah,
Okay, cool.
good reference point. Um, cool. Yeah. So unit test, Jess. So again, unit test, there's reading in here that you'll do on your own. There's some links to documentation as to what a unit test is. Unit test is usually the most appropriate place to apply a unit test is when you're writing a function and you want to test for a given input, what should the output be? Now, there's different kinds of tests, like end-to-end testing that you would write for like, testing a user login experience. That's going to be a little bit different. So we're not necessarily covering those kinds of exercises, but we are covering unit tests, which is basically testing, function inputs and outputs. So in your starter code, I do want to make a note that you're going to be given this numbers.ts file. And in your off-topic channel, I might drop some new starter code. Originally, I think there was 4 functions, maybe 5, and I've bumped it up to 20 functions. They are very straightforward. Not all of them. Some of them have like more of a layer of difficulty, but the goal is like to focus on writing the unit test. So I wanted to have more simple functions rather than shorter, more complex functions. So you want to make sure that you're starting with the starter code that I just dropped in our off-topic channel. So that should be in numbers.ts. And the way unit testing is going to work is that we're using the node or we're using the Jest testing system. So if you go to your package.json, you'll see that we have Jest is the library that we're using, our testing library. So when you run npm tests, and you have to do npm I first if you haven't done that in your starter code, you'll want to make sure you do that. And then when you run npm test, it's going to run this command, jest, which is our testing library, and watch all. And watch all is basically just going to look for any file that has a test.ts extension. So if I hit this now, I get no tests found because in your starter code, there is no test.ts file. So you'll be given the instructions. I'll just go ahead and demonstrate this. To create a file, you'll call it numbers.test.ts. You could call this anything you want, X, that's fine. Um, but because you're going to be testing the functions that are in numbers.ts, the general convention would be to call it the same name, and then the test.ts is how Jest knows to run those tests. So now, because I had npm test running, it's telling us that in numbers.ts, the test suite failed to run. Your test suite must contain at least one test. And, there's no test in here. So not a huge surprise. So what your challenge is going to be to take numbers.ts and just for our point of reference, because I'm going to close this file explorer over here. Numbers.ts and test.ts, they're siblings in the same unit test directory. So we'll need to have that knowledge in the back of our head in a second. And you're going to be given a number of functions that are broken. Now, if we were to look at this one, this function even numbers, it's going to take in an array of numbers. And it's going to, we're on that array of numbers, we're going to filter for each number. If that number is, if this is a true statement, n modulus 2, it's going to show up in our array that gets returned. So this is currently broken. You might be able to see it with your eyes. But if we're going to take this and put it in the browser, and this is written in TypeScript, so I got to get rid of the TypeScript syntax because TypeScript doesn't run in the browser yet. So if we take that and we do even numbers and we pass in our array of 1, 2, 3, 4, we see in fact it does the opposite. It doesn't save even numbers, it saves odd numbers. So chances are you might see like, oh, okay, the issue is that if we did have the number 2, 2 modulus 2 is 0, and 0 is actually a falsy number, right? If you remember back to truthy and falsy values, 0 is a falsy value, so 2 doesn't make its way in. But 1 modulus 2, so if we're looking at 1 modulus 2, the remainder is 1, so that is truthy, so it shows up in our array. So the way to fix this would be something like this. So now let's go ahead and run this, and we get 2 and 4. So that fixes our problem. And that's probably, on the junior side and even going to the senior side, that's how you've written your functions, is you've written them, you've logged their values, and you've seen that like, okay, this works, so this is what I need. Let me get back to the state. There you go. In the more towards the real world, every like professional developer job I've had, writing tests is huge. And the reason writing tests is so huge is maybe you all have experience in your projects when you're maybe like trying to refactor or you're trying to write code. Sometimes you write code for like a new something or you change code something somewhere and it breaks something else inadvertently. Um, Tests are what help you to catch those mistakes. Because when you start to maybe change a function that already exists to solve a different problem, you'll see how like you broke that function and what it was supposed to do. So the way we're gonna write our test, or the goal of this exercise isn't to do what I just did. This is how we've been probably solving problems up until this point, putting in console.logs. And eventually you may need to do that. It's not like that's a wrong thing to do. But in writing tests, what we do is we come up with the expected results first. So we need to, and this will be in your instructions, but at the top of your file, you're going to import, and all of these functions, I would just bring them one at a time as you're going to test them. Even numbers. So if we're going to work on that first, import even numbers. And the reason I mentioned that those two files are siblings is we can access it with /numbers. And then we're going to write our test. And I'm going to show you, there's a little demo here of how even numbers should be written. So basically, there's going to be a few keywords, and these are just keywords. Describe, it, expect, and to equal. Those come from the Jest library. So initially, this is how we write tests in Jest. We use the it keyword. I think you can actually, I think you can even use test. Just like JavaScript, there's a number of different ways of writing things. But we'll stick with the convention of it. And then it's going to take a label. It's going to take two arguments. The first is a label. So this test returns that even numbers. And we can kind of gauge from this description of what even numbers is supposed to do. Returns an array that contains only even numbers of the given array. So that's why I'm kind of coming up with that label. The second argument is this callback function. And don't let that throw you. You're just, you got your label, and then you got your callback function, which is going to have basically the code that you're going to write. And your code is going to have basically like three stanzas to it, three parts. The first line is going to be your arrange phase. This is where you set up essentially what your argument is going to be. So const numbers. So eventually even numbers, our function is going to take an array of numbers, right? Because that's what we're eventually going to like filter out the odd values from. So const numbers equals, I'll do 1, 2, 3, 4, 5. This is the arrange phase. The second is the act phase. And the act phase is where we actually like call our function that we've imported in, and we pass in the argument. So I'm going to do act phase. So const result equals even numbers. And again, we imported this in from another file. And we're calling even numbers with numbers. And so in our head, if we're thinking through like logically, how should this work? If we pass in this array of 1, 2, 3, 4, 5, and we are only returning even numbers, what should be the results? 2 and 4. And so that's the third phase, is the assert. That's where we're like saying this is what should be. So there's a number of ways in Jest. There's different asserts that we can use. And there's a link in our documentation to the Jest documentation and all like the helper functions that are there. You're going to be able to get away with using expect and to equal for everything we're going to use, but there's other stuff that's out there. So this is our assert. This is essentially where we're going to get our true or false. So we would say expect, and so this is a method from Jest, and we're going to pass in what this result is. So when we called even numbers, our function that we're importing in with this array, 1, 2, 3, 4, 5, that return value, right? The return value of that call, going back to code reading, is being assigned to results. So we're going to expect results, which should be that array of 2 and 4 to equal. And what should it equal? We've mentioned it a few times. It should be equal to an array with 2 and 4. So those are our three phases. So we can save our code. And it's taking a second to come through. And we can see that it's failing, right? And so it's giving us some feedback on what's failing. First, we see our label right here, returns even numbers, and there's an X next to it. And it's showing us like the line where the issue happened. and it's saying expected. Um, it expected two things, but it has a negative, meaning it's two of the things that were expected didn't show up, but it received three things that plus sign that aren't supposed to be there, right? So it was missing the two, it was missing the four, and instead it had the one and the three and the five. And that's we've written our test correctly. There's nothing wrong with our test. Um, so now we go to our code and we say like, okay, the issue is that this code is returning all the odd numbers and not the even. And that's where maybe you would might do some of the troubleshooting that I did over here in the console to see that, oh, it's giving us back the odds instead of the evens, and then change this to strictly equal to 0. And then when I fix the code, my tests are passing. So that's the goal of like where we want to be. And it's a different way of thinking about things. I think if you all remember maybe from like the very beginning, like week 1, when we had to do like the manipulation problems for object strings and arrays, how you had to write pseudocode for half of those problems. And you're like, oh, this is actually, it's hard to write pseudocode because I'm used to like just getting into the code, writing code, logging it, and kind of like troubleshoot my way into a solution and having to stop and write pseudocode first to determine the logic. It almost feels like it's harder. Um, and so this is almost like a step in that direction. You're writing the test um, with coming up with the understanding of given a certain input, what should the output be? And sometimes that's hard. It's a mentally different spot to get into. So it's a little bit of challenge, which is why we have a bunch of these that are more simple and straightforward, just because it's a different brain space to be in. Now, one other thing I wanted to demonstrate is you might have multiple tests. So for the sake of time, I'm just going to copy and paste in another test right here. So I'm using the it keyword. It works with an empty array, right? So const result, and here let's do this just to be consistent. So if we're calling this with an empty array, I think I have to put an any on here to fix that up. Okay. If we're calling this with an empty array and empty numbers, passing in numbers as empty array, we would expect the result to equal an empty array. So if you had some time to look at that, let that sink in, hopefully it's pretty straightforward. What we do see is that, we get a pass. So here's our label, returns the even numbers. Here's another label, works with an empty array. Because we're going to have 20 different functions, and you might have multiple tests for each functions, and the exercise leaves it to your discretion. There should be at least one test per function, but you might find it appropriate to maybe try to test for an edge case. So this would be like an edge case. Does our function still work with an empty array? Or this is what our expectation is. So what we can do in that situation is we can use a describe block. So describe, and then it's going to take two arguments. It's going to take a label, and this is just the label I would use is even numbers. So this is going to be a block of test for the even numbers function, and then a callback function. So just like we did previously. And this is all right here in this exercise, so you all can kind of refer to this for syntax reasons. And now I can take these two tests, and I can paste them in here. And so what I want you all to notice in the terminal before I press save is currently this is what it looked like. We had these two check marks. There's no way to know that they really belonged to each other, right? Numbers test.ts, but we're going to have a whole bunch of tests in here. So there's no way to know that these two tests belong to one function. So when I click save now, because I've moved them inside of a describe call, the output in the terminal is going to look a little bit different. We're going to have our even numbers, that label right there, appear right here, And then the tests that are nested within it are going to be like literally nested within even numbers. So if you have another describe block later underneath it, describe, maybe you have another function, odd numbers. Then those tests are going to appear under a different label, such as odd numbers. So it's just for human readability and organization. And then what you'll do is, once that works, then you can go ahead and your next function is going to be first element. So you can just do, these are all just named exports. So you can just write first element and import that in and start to write tests for it. Um, One quick thing just to demonstrate is that sometimes just for the sake of space, you could do all of this in one line. So I know this is a repeated test. There's nothing wrong with this. We could do expect, let me comment this out, even numbers and pass in the array 1, 2, 3, 4, 5. And you could do this all in one line. So if you didn't, if it felt redundant to do the arrange phase where you create the argument, and the act phase where you call the function, and the insert phase where you see if something is true or false, um, you can do it all in one line, and that's fine with me. Yeah. So yeah, real quick, any thoughts or questions on that? Of course, the exercise will kind of guide you through everything I just guided you through. Um, but yeah, any thoughts or questions? Sweet. Well, there are 20 of them. Um, so you can see some of them. Even the first element is the issue is the array is returning instead of the first index at index 0, it's returning the index 1, which is going to be that second element. So it's a quick fix, but the goal is like writing the test. So there's 20 of them. That can still take a good chunk of time. A few of them are definitely like a bit more complex, so they'll take some thinking. So don't feel that you have to sprint through all of them. Rule of thumb, though, is if you are stuck on something for 15 to 20 minutes, just reach out to me. There's no reason to be blocked on any of these for a long time. I'm here to get you unblocked. If it's for some reason I have staff meeting at 11 to 11:30 or it's break time or whatever, and like you don't want to be like blocked for a longer amount of time, jump onto the next problem, start working on the next problem. So 20 of those should take you a good bit of time. And then what we'll do is we're going to work on these like all morning, and so if you might wrap that up in an hour and a half or something like that. And then we'll do the Q&A, which we won't go through all 20 of them after lunch, but we'll go through a few of them after lunch. But if you do finish that up early, then the other exercise I want to point you to is CD practice exercises. Um, Real quick, do either of you remember these? They aren't a part of this actual class's repo anymore, so I added them. Do either of you have any remembrance? It's okay if you don't. They may or may not have been passed out.
I believe you handed those out on the junior side. They were
Yeah.
like optional just for additional practice before we
Yep.
got into React.
Yeah. Yeah. So yeah, let me go through this. So this is how you can spend some extra time. Each of these are going to have like a number of challenges within them. And so you'll need to do an npm install in this if you haven't done that yet, because it's working with the Jest testing library. But essentially what you'll do is I would probably start in the beginning. They start off pretty simple for the most part, but then they grow in complexity. So there's no reason starting with the easiest ones in the beginning just to kind of get your, build some momentum. But you can skip them as well. You don't have to do them in any specific order. But the way they're set up is that there is a test.ts file and there is your actual code. So in the test.ts file, you'll see that hello world is being imported in from the file hello world. And here's what the test is. So this will give you more experience of like after you've written all your tests, you've gone through all that work. If you have extra time on your hands, you start to go through these, you can see like, oh, you can see the test system being used. And so the result is that when we've imported in the hello world function and called it, and the return value of that call is saved to the variable result, that we're going to expect that result to be or to equal hello world, the string hello world with an exclamation mark. Now here's where like the tricky thing that you'll want to kind of keep in mind is that if you do npm test, it's going to run tests because we're just at this practice exercises point in our code. So it's going to run all the tests for all the files. So there's 75 failed. That's a lot. And so what you can do is you can filter the test to run just the ones that are in either the folder that you're in. So there's this watch usage down here. And there's probably a number of ways you could do what you want to do, but pressing letter P will allow you to filter by a file name regex pattern. So I'm going to type in P. And what's the pattern? You could do the file name or even just the folder. So I'll just do O1 dash hello. And there's nothing else I assume that's going to match that in here. So now when I run it, I see that there was one test that ran. You learn to read the errors that, we expected hello world, the string, and instead we got an empty string. So then we go to the function and we see like, okay, this is the function. What is hello world supposed to do? It's supposed to return a string. We look what the test says. The test is it's supposed to return the string hello world with an exclamation mark. So we write hello world with an exclamation mark. And we save it. And we see that our test pass. So we're all good. So now we might want to move on to the next folder of get sum. So just the clue of how to get back there is you could do Control C or whatnot. But if you just press W, it'll take you to your options. And then you can press P to filter by regex. And then it's going to be O2 get sum. And that'll give you your failed test for get sum. And you'll look at what the error is, or you'll look at what the test is, and then you'll go in and fix the code to match that. So that's if you have extra time between now and lunch, or just any other time while you're in the program and you're just looking for some ways to build repetition. I know I talked about Code Wars being a good site. This is actually a nice built-in thing, and that's just in your system. That's kind of like tailor-made for like LearningFuze students in the level that we're at. So that's also a great place to be as well if you're just looking for algorithm growth. Yeah, so with that said, that's all I have. Any last minute questions before I let you all dive in? Sweet. 10:30, 10:55 is break. I have staff meeting 11 to 11:30-ish, so I'm going to go a little quiet during that time. By any other point, while you're working, once you're stuck 15 minutes, reach out to me, get unblocked, keep moving, and then I'll have a message for all of us about how we'll do the Q&A after lunch because 20 exercises is too much, but I'm gonna have each of you maybe walk through like 2 or 3 of the tests that you wrote just to get practice talking about code and demonstrating code. So yeah, dive in and reach out if anything comes up.